Okay, in the previous section, we talked about how to find a least common denominator. And we spent a whole section practicing that because finding the least common denominator is really important when we are adding and subtracting rational expressions. So again, let's relate this back to just working with plain old regular fractions that we saw in elementary school. So if we have something like this, 1/8 plus 3/8, when we are adding and subtracting fractions, we must have a common denominator. If we don't have a common denominator, we can't add them as they are. So in this case, we do have a common denominator. So we keep that denominator the same, and we add our numerator. So 1 plus 3 gives me 4, so we get 4/8. After we've added them, we always see if we can simplify. 4/8 is going to simplify to be 1/2. Okay, but a lot of times we do not have a common denominator. So we'll see an example down here, but again, just to kind of refresh you before we start, if we have something like this, 1/8 plus 1/4, we can't add these as they are because our denominator is not the same. So we're going to have to change these to get a common denominator or to find our LCD, least common denominator, so that we can add those. And we will, when we get to example 348, we'll talk about how to do that. Okay, so on 346 and 347, we have rational expressions. We have more than just a simple fraction going on here. We have binomials on top, trinomials on bottom. Okay, so you'll notice here, we do have a common denominator. We have the same thing on bottom here and here. So that's nice, so we don't have to do anything to change this before we add or subtract. We keep our denominator the same, x squared minus 2x minus 8. And then we add our numerators. And when we're adding these, we're basically just combining like terms. So x plus x gives me 2x. Negative 4 plus 8 gives me positive 4. So we have 2x plus 4 on top, x squared minus 2x minus 8 on bottom. And just like we did up here, after we add, we see if we can simplify. We're going to do the same thing here, but our simplification process looks a little bit different since we have a binomial on top, trinomial on bottom. To simplify, remember, we just see what we can factor. So on top, we can take out a greatest common factor of 2. I'm left with x plus 2. On bottom, I can factor this trinomial into 2 binomials. I have to think of 2 numbers that multiply to give me negative 8, add to give me negative 2. Well, that's going to be a negative 4 and a positive 2. Okay, we look for matching factors on top and bottom that we can cancel. And so our final answer is we have a 2 on top, we have an x minus 4 on bottom. Okay, similarly on example 347, we have common denominators, 3x minus 6. One thing I do want you to be aware of is that we're subtracting here. So we're going to have to do minus 15x minus negative 6 or plus 6. So just when we combine our numerator, we're going to have to keep that in mind. Okay, so because we have common denominators, we can just jump right into subtracting these. Denominator stays the same. Our numerator, we have 6x minus 15x. And if it helps you, you could, here, let me erase this. You could just change this. You could say, okay, I'm going to change this to minus 15x plus 6. If that's easier for you to kind of wrap your head around, we can do that. So 6x minus 15x gives me negative 9x. And then we have a negative 12 plus 6, which gives me negative 6. All right, so if we're simplifying from here, we're going to see what we can factor. I can take out a negative 3 from the top, and I'm left with 3x plus 2. On bottom, we can take a 3 out, and I'm left with just an x minus 2. Okay, we can't cancel our binomial factors there, but I can cancel this and this. So we're left with, we still have that negative 3x plus 2 divided by x minus 2. And we can leave it like that. If you wanted to distribute that negative back in, you could. It's going to be equivalent either way. All right, so starting from here, from 348 and beyond, notice we do not have common denominators. So we're going to have to find that first before we can add. So I'm going to put a big star here, and I'm going to put find the LCD first. Remember, LCD stands for least common denominator. That's what we practiced finding in the last section. Okay, so we just have plain old fractions here. I'm going to go ahead and just rewrite both of these. What we're going to do on bottom here is we're going to find our least common denominator, and it's going to go in both places. And then we're going to see how we need to change our numerators from there. Okay, so we have 6 and 4. We're kind of thinking of the multiples of those. What number will they both go into? So 6, 12, 18, 24, 4, 8, 12, 16. Well, they both go into 12. 12 is their least common denominator. And now we have to think, okay, how did we change the denominator to get to 12? Well, we multiplied 6 by 2. So we're going to do the same thing on top. 2 times 5 is 10. We multiplied 4 by 3. We got to do the same thing on top. 1 times 3 is 3. Now we do have common denominators. So now this is like the problems above. We just keep our denominator the same. We add our numerators. 10 plus 3 is 13. You can keep it as an improper fraction, or you could change it back to a mixed number if you want to. You cannot simplify this at all, so I'm fine if you leave it just like that. All right, the next one, we have some variables and exponents. So again, they're not common denominators. So I'm going to give myself some space to rewrite my fractions here. And we've got to decide what we want their denominators to be. So let's take it piece by piece. 3 and 6. Well, the least common denominator of those two things is 6. So we need a 6 in there. All right, let's look at our a's. We have a squared and a. We're going to have to use our highest power. So we need a squared. And then our b's, we have b to the first and b to the fourth. We're going to have to use our highest power, so b to the fourth. Okay, so our common denominator is 6a squared, b to the fourth. So now I know it's going to feel different because there's letters, but we're essentially doing the same thing that we just did. We're saying, what did we change our denominator by to go from this to this, to go from this to this? However we changed our denominator, we're going to also change our numerator the same way. So on this one, let's see, we had to multiply our denominator by a 2. It already had the a squared, and it has a b to the first. We need b to the fourth. So I need to multiply it by 2b cubed to get to our common denominator. All right, so if we multiply the bottom by 2b cubed, let's do the top by the same. 2b cubed times 7a is going to give me 14ab cubed. And then our second one, let's see what we need here. We have a 6, we need a 6, so we don't need to change our numbers. We have an a, we need an a squared, so I need to multiply it by a. We have a b to the fourth, we need a b to the fourth, so we're okay there. So we can just multiply the top and bottom by just by a. So 4b times a is 4ab. Okay, we are ready to go ahead and add these. I'm going to move it down here. We keep our common denominator, 6a squared, b to the fourth. And these are not like terms, so we can't combine them, but we can write them like this. 14ab cubed plus 4ab. All right, we do have a binomial on top, so let's see if we can factor and simplify it all. We can definitely take out a 2. We can take out an a. We can take out a b. If I do that, I'm left with 7b squared plus 2. On bottom, we haven't done anything. 7a squared b to the fourth. Okay, now let's see what we can cancel out here, what factors we have in common. Well, this 2/6 can simplify to be 1/3. This a can simplify with one of these. so we just have an a on bottom. This b can simplify with one of these. We had b to the fourth, we now have b to the third. So I know that's a little bit messy. Let me rewrite it. So we're just going to have 7b squared plus 2 on top. And then on bottom, this changes to 3ab to the third. And that's as far as we can simplify this. Okay, let's do a few more where we need to find a common denominator. So for example, 350. I have two denominators. I have 5a and 4a squared. And we are subtracting here. I'm going to go ahead and highlight that so that we don't forget. So let's think about our denominators. We have a 5 and a 4. Let's think about their LCD, their least common denominator. That's going to be 20. And then if we look at our letters, we have an a and an a squared. So their least common denominator for our a is going to be a squared. So we're thinking, how did we change our denominators to get from what they originally are to 20a squared? Well, for this first one, we're going to multiply it by 4a. Do the same thing on top. 4a times 4 is 16a. Let's see this one. All we have to do is multiply that by 5. Do the same thing on top. 7b times 5 is 35b. Okay, we now have common denominators, so we're going to keep the denominator the same, 20a squared. And on top, we get 16a minus 35b. And if we check the top to see if we can factor, there is no greatest common factor there, so we can't do anything. We leave it just as it is. All right, so example 351 is the first one where we see that we have a binomial in the denominator. So anytime we see a binomial or a trinomial in the denominator, my tip for you is to factor the denominators first. So actually, hold on. Factor denominator first. To find the least common denominator. So if we see, like especially on this next one we're going to do, we see a trinomial, before we do anything else, we're going to factor those. Okay, so this is the only one I can factor. I can take out a 4, and I'm left with 2a plus 1. So I'm just going to scribble that out. We have just rewritten that as 4 times 2a plus 1. Okay, so now I'm going to draw my two fractions. We're going to see what we need to do to find our least common denominator. So again, let's look at our numbers first. We have a 4 and an 8. Well, 8 is their least common denominator. So they both need to have an 8. And then this one has a 2a plus 1. This one does not have a 2a plus 1. But since this one has it, it needs to be in our common denominator. So 2a plus 1 and 2a plus 1. So factoring really just helps us see what we already have and what we're missing to get to that common denominator. Okay, so let's see how we changed our original problems, or our original denominators, to get to our new one. Okay, well this has 4 times 2a plus 1. The 2a plus 1 is already there, but I need to change that 4 to an 8. So I'm going to multiply the denominator by 2 and the numerator by 2. 2 times 6 gives me 12 on top. For this next one, it already has the 8, but we need it to have that 2a plus 1. So I'm going to multiply it by 2a plus 1. Same thing on top, 2a plus 1. And I'm going to go ahead and multiply that out because we're about to need to combine those numerators. So we want it simplified. So 3a times 2a is 6a squared. 3a times 1 is 3a. So we now have common denominators. So we leave our denominator the same. And notice I'm going to leave that factored because our last step is always to see if we can factor to simplify. So if we undo that factoring, we're just going to have to redo it at the end. Our numerators, we are adding. There's no like terms, so we just have 6a squared plus 3a plus 12. And if we wanted to see if we could factor and simplify, if we look at our numerator, we can take a 3 out there. we're left with 2a squared plus a plus 4 divided by 8 times 2a plus 1. And this right here, you may look at this and say, hey, that should be able to factor. If we try to factor that, it's actually prime. It's actually not factorable. So we can't do anything else from here. So you could leave it like this, or we could leave it like this. Either way. All right, and then our last one here, we have a binomial as a denominator on the first one and a trinomial on the second one. So again, we said it's a lot easier to find a common denominator if we write these in factored form, if we factor this trinomial. So two numbers that multiply to give me 12, add to give me -7. We're going to have x minus 4 and x minus 3. I'm going to just scribble that out so we don't get confused. We've just rewritten it in factored form. Okay, and this helps me see how to change the fractions. Because if we look right here, they both already have x minus 4. So we know that needs to be in our common denominator. But this one also has an x minus 3. So we need that to be included also. So put that in both of them. So now what we're going to do is say, okay, we're going to check each fraction and say, what do we need to multiply this by to make it from what it is originally to our common denominator? Well, this one already has an x minus 4, so I'm going to multiply it by what's missing, an x minus 3. Do the same thing on top. And I'm going to go ahead and distribute this out. Again, we're going to have to combine our numerators, so I'm going to go ahead and distribute that out. I'm going to write it down here, and then I'll write it simplified in our fraction. X times x is x squared plus 1x minus 3x minus 3. When we combine our like terms, we get x squared minus 2x minus 3. Okay, for our second one, we already have the x minus 4. We already have the x minus 3. So we actually don't have to change that at all. Just x plus 1. Again, don't forget that this one is subtraction, so this is really minus x minus 1. So if it helps you, we could say, okay, I'm going to change that to minus x. Maybe I'll just write it above. Minus x minus 1, either way. All right, so when we add these, our numerators we just combine. So we have x squared, negative 2x, and a negative 1x is negative 3x. Negative 3 and a negative 1 is negative 4. Our denominator stays the same. Now we see if we can factor to simplify. Our numerator is going to factor to this. X minus 4, x plus 1. Two numbers that multiply to give me negative 4, add to give me negative 3. Denominator is already factored. X minus 3. So now we cancel out our common factors, and we're left with an x plus 1, x minus 3 on bottom.